Decision making under uncertainty includes 5 methods covered in the text beginning on page 323. These methods are the maxi-max, maxi-min, criterion of realism, equally likely, or minimax with regret. Take a look at each of these methods using the sample data provided. You may want to pause the recording and put these headings on a worksheet so that you can work through the problems. In this scenario, we have 3 alternatives. Alternative 1 is to build a large plant. Alternative 2 is to build a small plant, and alternative 3 is to build no plant. We have 3 levels of demand, a high level, a moderate level, and a low level. High demand, if we build a large plant, we're looking at $200,000. Small plant, $90,000 under high demand. And nothing if we don't build any plant. Moderate demand with a large plant, $100,000. Small plant, $50,000. No plant, 0. Low demand, we lose $120,000. If we build a large plant, we lose $20,000 if we build a small plant, and then 0 if we take no action. The maxi-max criteria maximizes the payoff over all other alternatives. It's sometimes called the optimistic criteria. To calculate the maxi-max, you take the maximum of the alternatives. So we'll use Excel to max of build a large plant, and the max build a small plant with relative cell references. Of course, we could have just copied this down. Then we can look and see the maximum of the maximums is $200,000, but we use a statement, an if statement, to determine that. Equals if the value to my left equals the maximum of the values to my left, make that absolute, then it's the best choice. Otherwise, we'll leave it blank. The maxi-min criteria is the opposite. It takes the maximum of the minimums. It's the pessimistic criteria. So we'll go ahead and calculate the minimum of the options, the alternatives. We can copy that down. And we want to take the maximum of the minimums. If the value to my left equals the maximum of the values to my left, then it's the best option. Otherwise, blank. The Hurwitz criterion of realism requires the addition of an alpha value. Hurwitz weights the level of optimism and the level of pessimism in the decision-making process. The alpha value represents the level of optimism. So if someone is generally optimistic, 60%, the Hurwitz method would multiply the maximum outcomes, the optimistic scenario, times 60%, weight it at 60%, and then take the minimum payoffs, the pessimistic outcome, and weight it at 40% or 1 minus the alpha. Then it would add the two of those together, and that would give the realistic assessment of the value of the alternative. So we'll go ahead and place the alpha value here. We can have Excel insert a symbol, Greek letter A for alpha. Our example has an alpha value of 0.45, so we'll put 0.45 here. So for the realism value, we'll take the alpha value, make that absolute, and multiply that times the maximum of the outcomes for each alternative. Take that quantity and add it to 1 minus the alpha value, make that absolute, times the minimums of the alternatives. Copy that down. The choice is then the maximum of the realistic appraisals of the payoffs for each alternative. So if the value to my left equals the maximum of the values to my left, then it's the best choice, otherwise blank. Equally likely is simply the average of the alternatives. So we'll take the average, the outcomes for building a large plant, and then the average for building a small plant and building no plant. And the choice then is the maximum of those outcomes. So if the value to my left equals the max of the values to my left, that absolute, then it's the best outcome, otherwise blank. The final method in this section is minimax with regret. We'll put together the headings for that. You may want to take a moment and pause the video, copy these. Minimax with regret simply takes a look at all of the options under a particular level of demand for the alternatives, and then determines how much we leave on the table, what our level of regret is by choosing each alternative. For example, the maximum of the high demand alternatives minus the high demand for building a large plant, 200,000, leaves nothing on the table. If we build a large plant and demand is high, we make the maximum, the highest option at that level of demand, or $200,000. Now if I copy these down, you can see that if we build a small plant, we make $90,000 if demand is high, so we leave $110,000 behind. That's our level of regret. If we build no plant, we don't get anything, so we lost $200,000. Again, our level of regret. By locking the rows in the max formula, I'm then able to take these and copy them across and determine the level of regret for each of the other options. In order to take the minimum of the maximums, I have to first calculate the maximum for each option. The max for building a large plant is $120,000. For the other two options, $110,000 and $200,000. So the minimax, the minimum of the maximums, I want to minimize my regret if the value to my left equals the minimum of the values to my left, and it's the best option, otherwise blank.